Yesterday, in 12th class, live class, uh, student, I did mini problem uh, based on my dear, that is Coulomb's law, right? Okay, uh, student, in today class, I'll first like first I'll cover few topics. Like yesterday I said Coulomb's law in air, right? Now, beta, here I'll start Coulomb's law in a medium. What, my dear? Coulomb's law in a medium. So, beta, just give me few seconds. Beta, just give me a few seconds here. Right. Then, beta, I'll start the class as it should. So, what, my dear? Here I'm going to start with just this is Coulomb's law in a medium area. What, beta? So, this is, I can say, topic of today class, my dear, for 12th class. This is Coulomb's law, student, in medium. Okay. So, bacha, how can we do this question idea? How can we understand this concept with the help of diagram only? Right. This is the language of ABT. So, what is the concept, beta? You can take there is what? Beta, two identical, I can say, charge ball. Right. So, here you can take, here I'm placing my dear. This is the thing into different case. So here, student, I'm considering initially, this is what you can say, I can say pair of, we can say like charge ball in air. What may be in air, and beta here, I can say stretch in medium, right? So beta in air, I'm calling pair of charge particle. Beta, this is Q1, my dear, this is Q2. Let us suppose both are separated at a distance r. My dear, same charge particle, beta. This is what you can say Q1. This is what, my dear, Q2. Right, beta, this condition. Again, I'm assuming distance is remains r. Right. Okay. Here, students, I wanted to write force in both of the cases. So here, beta, I can say this is your force in vacuum or air. Beta, this I'm calling FV, beta. Yesterday I gave you formula, everyone. This is what, my dear. This is K Q1 Q2 by R square. Beta, God bless you for your direction, my dear. K Q1 Q2 by R square. Now, which I hope all of you remember here. Yesterday already I said K is what, my dear? 1 by 4 pi epsilon h. In fact, beta, I can say this is the epsilon r. Beta, here I can discuss this with all the points here. Why yesterday I said directly 1 by 4 pi epsilon h. Beta, there is something you have to discuss separately, beta. So just also, my dear, I'll tell you a few basic points. Like, beta, no, this is epsilon. High student, epsilon, beta, I can write. This is what, my dear, epsilon naught into epsilon r. Where, beta, I can say epsilon is what, beta, permittivity of free space. Beta, this is, beta, what you can say absolute permittivity. What, my dear, you can say this is absolute permittivity. Beta, this is study I said here. This is what, my dear, permittivity. Permittivity of, beta, this is free space. Permittivity of free space. Beta, what about epsilon r, my dear? This is relative permittivity. What was a relative, beta, g permittivity, right, beta? Okay, so here, students, I'll discuss here individually. Beta, God bless you, beta, for your reaction, my dear. Okay, beta, here I'll discuss here. There is 2 point. Student, this is beta, I can say, beta, first I'll discuss for air, or beta, I can say vacuum. This is what, my dear. Uh, can I come to your channel? Ah, yes, why not? Yes, you can join beta. You can get benefit beta. You can get benefit beta. It's free of cost for all students here. I'm just loving your content. Okay, okay, beta. God bless beta for your beta like appreciation. Hi, student. Okay, now beta for air beta. For air beta, I know this is beta formula, my dear. Epsilon is what beta? This is epsilon naught into epsilon r, right beta? Okay, beta for air, beta ji for air, you can take beta epsilon r is equals to 1 beta ji. So here you can write, my dear, epsilon is equals to epsilon naught. So you know beta, yesterday I taught you Coulomb's law in vector form. Uh, Hi student, beta epsilon is what? Epsilon naught. Beta yesterday I used thoroughly because yesterday I discussed all numerical of Coulomb's law based on, my dear, only air or vacuum. So beta this is what you can say, epsilon is equals to epsilon naught. Beta g epsilon is equals to what, my dear? Epsilon naught. Okay. So here you can say bacha, here bacha you can say yes, beta. So due to this beta, yesterday I used directly here. K is equals to what, my dear? 1 by 4 pi epsilon naught. Beta, right? Right, my dear? Okay. Now, beta, I wanted to discuss here for, you can see, my dear, for medium. For medium. Okay, fine. Sir, which is J on. I can say, beta, for J, beta, if you are good in mathematics, beta, you have a basic approach. Beta, can you write your name, bacha? Then I can help you, bacha, more. Uh, I can say, beta, those ask the questions. Okay, okay, fine. Barsha, beta, I can say if you are beta good in mathematics, then beta you can go for JEE. Beta, if you are not much confident in maths, then beta go for NEET. Yes, beta. Other or another way, beta, I can see both are possible. Both you can do easily. Beta, have a look here. Beta, I explain, my dear, for air bacha, I use, because yesterday I use multiple time. This is what? 1 by 4 pi epsilon net only. For medium bacha, what I said, epsilon r is equals to 1 beta for air. Right, my dear? Here bacha, again I can say epsilon is what, my dear? Epsilon into epsilon r. Here beta, epsilon r is always greater than 1 for medium. Beta the epsilon r beta always greater than beta 1 for medium beta, right? So here you can write, my dear, k is equals to always beta for medium 1 by 4 pi epsilon naught into beta epsilon r, right? So beta here you can write beta, this is what, my dear, f medium force beta. This is what beta you can say k dash or k prime into beta. Beta, God bless you, dear, for your reaction. K Q1 Q2 by R square beta G. Right, my dear? You can see this is 1 by 4 pi epsilon naught into epsilon R beta G Q1 Q2 by R square. So, beta, this is what you can see medium force. But I know J asked beta G directly multiple times these questions. Oh, hello, student Aryan. How are you, beta? Very good. You can beta just try one more time, beta. So now, beta, just I'm going to beta conclude. Now, students, I'm going to conclude beta ji Coulomb's law in a medium. Now, beta ji, I'm going to conclude here. That is, beta, I can say Coulomb's law in a medium, beta. So this is the fourth beta which I wrote, beta ji here. You can see, my dear, this is 1 by 4 pi epsilon naught Q1 Q2 by R square. This is beta G, I can say vacuum or air force. Beta here I wrote beta, this is the medium force. Beta again here I wanted to write. Beta I'm from Bangalore, my dear. Okay. Bacha ji, I can say beta just take ratio beta. Beta just take ratio bacha. So beta again I'm writing beta once force in a beta air. Right, beta? This is what? 1 by 4 pi epsilon h beta g q1 q2 by r square. Right, beta g? Okay, medium force beta we already found. 1 upon 4 pi epsilon naught epsilon r, my dear, q1 q2 by r square. Beta take beta division. FV upon FM. What you can say, bacha? So this is what will get epsilon r. So beta I know G beta directly asked student this beta multiple time. My dear J asked beta G this statement beta multiple time, bacha. They used multiple time. If what is the relation between air force to medium force? You can use thoroughly beta, that is epsilon r. Now beta, I'm going to give you one question here based on this. And that question beta literally very useful and very powerful beta. God bless you dear for your reaction and like the video, my dear, and like my content. I'm very happy to see everyone. God bless you at Physics Point. All of you welcome. Stay at Physics Point, join live classes. If you have any queries regarding your content, regarding any subject, like say physics, any chapters, you can write your concern comment box. I'll back and help you according to your expectation. Every day I'm coming for live for 11th class. There is separate time. This is time beta 12th class going on. I'll take these classes till 2:30, right? So beta, all of you, welcome at this one, bacha. Beta, just we continue class here. So what is student? I can say questions is that, beta, you can take like that. This is students, I can say initially you have a pair of charge particle. Student, this is the beta, I can say pair of charge particle. You can say beta both are identical, my dear. Both are identical, my dear. You can take beta mass m, beta g charge q. You can take beta mass m and beta you can say charge q. Right. Okay. Now beta you can say initially beta they are I can say this pendulum making angle theta from vertical. Making angle theta from vertical. This is beta initial condition, my dear. Okay, now beta, you can say because no beta, this is the concept of pendulum here. So my me to take this question as the example, so that I can tell you about concept of pendulum as well as numerical based on this. That's all, that's party. And beta, I know this is the question asked by beta JEE two times. JEE beta, God bless you, dear, for your reaction, my dear. JEE beta asked these questions two times, my dear. Right? Okay. So this is beta. I'll take our individual. See, in fact, beta, I can say this is case one for this question, beta. Uh, okay. Today means today is 28. Which shift, beta? Suryansh Sharma, which shift will you go to write exam, my dear? Morning shift or evening shift, beta? Okay, this is case one beta, right? So beta, first we'll do your PhD beta for case one. Second, okay, all the very best beta. You can go beta and watch the video. Beta is suggested multiple question beta. You can go and search like say on YouTube, Physics Point BK Sir. Beta, what's the lecture name here? Understanding beta. There is a beta thumbnail. Understanding beta buoyancy force. Beta, in 11th class beta, there are few students came. So I explained which topic you have to do. Beta, go and watch beta that lecture. That video will help you a lot, my dear. Anyone is here present? Anyone is here present? Those have a link for that video. Please share that video in chat box. If anyone has a link of that video, please share in chat box so that Suryan Sharma can watch that relevant video. Anyone has, so please share in the chat box. Now, beta, have a look at the questions here. So you can see beta system beta, this is remains in equilibrium beta. What you can see, this pendulum also making theta beta from vertical. This angle beta also S beta. God bless you, my Suryan's dear. God bless you, my Suryan. Suryan Sharma. Uh, okay, beta. Mass m beta, charge q beta, mass m charge q beta. System beta initially in equilibrium. System beta what? Initially in equilibrium. Okay. If system is initially in equilibrium beta z, then beta just make ABD here. So beta, if we'll make ABD beta, you know this is a like charges, so repel each other, my dear. You can say, bacha, this is what mg force. This is what mg force. Beta, you can say this is what, my dear? This is what Fe, force due to electrostatics. Force due to electrostatics. I hope all of you know tension is always acting along this stream. So beta, you can say, my dear, this is a theta, so this is what remains theta. Beta, this is a tension stream vector, so you can say this is what t cos theta. Now, beta, you can say this is what t sin theta. Beta, you can equate beta. Now you can see system is in equilibrium. You can say bacha system is in equilibrium. If system is in equilibrium, beta, then you can write bacha party for this condition. Beta, equate all the forces bacha. Total upward force is equals to beta what you can see total downward force. Beta right force is equals to left force beta g. So you can write this is t sine theta which is equals to Fe. T sine theta which is equals to beta what you can see Fe, right? Bacha, I can say, bacha ji, uh, T sine theta, what you can see? T sine theta, which is equals to beta, you can see Fe. T sine theta beta ji, which is equals to what you can say Fe, right, beta? Okay, then bacha, buddy, you can see, bacha, this is T cos theta. You can see, bacha, this is T cos theta, which is equals to beta ji mg. Beta, just beta, divide these two. You can see beta equations number one. Now beta you can see equations number two. Right beta. So you can write beta party just divide. You can get beta tan theta is nothing but this is what, my dear? Fe by mg. Beta say equations number third. Say equations number third. Right, my dear? Okay. Now bacha I can say beta just beta this is case one bacha. Now beta ji I'm going to explaining bacha same concept beta. This is what case two. In case two beta same concept same data bacha. What's mentioned student for this condition? Uh, bacha ji you can write, my dear, theta is remain same before and after beta. This is keyword for this question. Beta ji theta is, you can say beta theta is what remains same for you can say remains same beta before and after beta g before and beta g after, right? So beta once you will dip beta inside entire setup beta if will beta dip in the liquid, so theta remains same beta. This is the mean beta party. So you can say, my dear, this is what basically you can say container. This is beta I can say setup of pendulum. Now students you can say entire setup you are what dipping in water. But there is one point beta you can say theta remains same beta, which is theta beta both of the pendulum making from vertical. This is remains same. You can tell beta this is also theta beta z. You can say this is also theta beta. Beta God bless you for reaction, my dear. This is again here we just beta make ABD, my dear. So you can see beta for this condition. Beta, I'll make a video beta here only so that you can easily understand, my dear. This is beta Z. Because as for this point here, I'm always trying to curate the content so that you can get benefit of this point everywhere. Now, bacha, you can say this is what theta beta. This is theta bacha ji. You can say this is what remains theta. M beta ji, you can say what? This is basically mg. Everyone know tension always acting along the string, my dear. So you can say beta, God bless you, dear, for your reaction. This is what t cos theta. Now, students, you can say this is what t sin theta. Beta, this direction you can write, my dear. This is what Fm. Fm is what, my dear? It's a medium force, right, my dear? Okay, beta, one more thing, beta. No, this is what. If you are something, beta, you are dipping in a liquid. So there is one more force, beta. This is what you can say 1c force. This is what, my dear? 1c force. Now, beta, I can say entire system is in equilibrium. Beta, what I can say? Entire system is in equilibrium. Okay. Now, beta, if entire system is equilibrium, beta, then what you can say, bacha? You can write, beta, for vertical equilibrium. Beta, you can write for vertical equilibrium, beta. This is what, beta? Buoyancy force, beta ji, buoyancy force plus tension, which is equals to right mg force. Say equation number one. Then beta, I can write beta this horizontal bacha party. This is three bacha, so you can say this is what equation number four. Beta just equate beta horizontal forces, my dear. So you can write there is one thing missing bacha. FB plus, just write one more beta, FB plus T cos theta, which is equals to mg, my dear, right? Okay, beta, this is what you can say equation number four. Now, beta, just equate your horizontal forces, beta g. Then what beta can write? T sine theta. What beta? T sine theta, which is equals to Fm. Beta, just equate at these two. How beta? I'll write here once again here. Beta, this is, I can say beta, I'm writing equations for vacuum beta. So you can say this is T cos theta plus Fv is equals to mg. Beta, we wish to find T cos theta here. Just separate beta. Mg minus, you can say Fv. Now, beta, you can see this is what equation number you can write, beta. Already, something, yeah, you can see this is the four, beta. Previously, yes, this is the four, beta. This is four. This is five, beta. You can see, beta. This is six. Beta, you know what is equation number five, beta? This is t sine theta, which is equals to fm, beta. Just equate here this equation, these two equation, beta. Divide beta 5 by 6. You can tell beta this is a tan theta. You can write Fm upon beta g mg minus Fb. But let us suppose equations number 7. Beta, you know, in the questions, according to questions, beta, it's a good questions, yeah, beta. It's literally very good question, bacha. It's a beta very good question, yeah. Okay, beta, this is what you can write, bacha ji. You can say, bacha, tan theta remains same, bacha. So what is tan theta, beta? We got initially. This is what Fe by mg, beta. Fe by mg, my dear. Right. So you can write, bacha, these two beta equate. This is Fe by mg is equals to beta. This is Fm upon beta mg minus Fe. Just beta, this take ratio here. You can say Fe upon beta. This is what you can say Fm. It's nothing beta. Already I proved this result, beta. Beta, already I proved. Are you listening, sir? Yes. Yes. Tell me. Tell me yes, is. Okay. Now, beta. Fe by Fm beta. What you can see? Fe beta what? This is beta. Fe by mg beta. And this is beta. I can say this is Fm upon beta mg minus Fb. Okay. Now, beta. This beta. Do one thing here. You can say this is F E upon Fm is equals to, you can write beta mgr. Beta, this result just now I proved beta g. I can show you beta. FV by Fm is what? Epsilon r beta. FV by Fm is what beta g? Epsilon r. So beta, this is what, my dear? This is what, my dear? You can say epsilon r, which is equals to what beta? Mg minus Mg minus beta buoyancy force. Beta Mgr, I can write here density of material into volume into G. Buoyancy force beta, maybe all of you know here. Buoyancy force beta, you can say this is what? Density of liquid into V into G. Right, my dear? Beta, I'll use beta this result over here only. So epsilon r beta, you can write mg beta, already I wrote. Density of material V into G upon beta, mg beta remains same. Density of material V into G beta. Okay, minus beta buoyancy force here. Density of liquid V into G. Beta, I can take common beta Vg in denominator. Then beta cancel. Now onwards beta J one time asked directly beta. J beta one time asked directly. This is the result only beta. Density of material upon beta the density of material minus density of liquid. Beta in 2024, as I remember, they asked one time, this is the same result, and beta one time they asked, yes, in 2025, 2024, whatever, data-based questions. So we remember beta, this is highly recommended questions. Those candidates will go to write tomorrow exam. Beta, keep in your mind this formula. Okay, so this is all about beta. I can see Coulomb's law in a medium. Coulomb's law in a medium. Now beta onwards here, I'll do the questions only. Right, beta, this is. Now what's the next reading here? Concept on pendulum. What was the next reading? This is, my dear, this is concept on pendulum motion. Yes, beta. Concept on beta pendulum. Already I explained with you what is the concept on pendulum, my dear. Okay. So beta, we'll do the questions only here. Right. Let's do one thing here. Just I want to tell you a few points. Student, I wanted to tell you a few points about pendulum. But it's related here. This is what you can say 5C2 type numerical. Bacha ji, this is what remains mass m bacha. You know, beta, this is here I'm considering theta from vertical. Beta, this is what theta from vertical here. You can tell, my dear, this is what tension remains T. So this is what beta, you can see remains theta here. So you can say this is what T cos theta beta. This is what you can write T sin theta. This is what mg beta. You can see both have mass m and charge also remains the same. Mass m beta, charge remains same. So like charges beta, what you can say repel each other. Right. You can write with the system is in equilibrium. System beta what? Okay, you can see is in equilibrium. At equilibrium condition, my dear. At equilibrium. Just now I finished here, but still I'm repeating because I wanted to convey a few points based on this beta. At equilibrium beta g, what you can say T cos theta which is equals to mg. Say equation number one beta. Now which I